give you guys an overview and hopefully an idea of some potential applications. And when I say potential applications, I do want to, one of the themes that I'm going to be talking about throughout this presentation is, flexible hybrid electronics is a new emerging cutting edge technology. So we really don't know all the applications and where it's going to end up and what the use cases are going to be. And part of this presentation is to bring awareness to you as manufacturers to say, hey, here is an emerging technology. What are some of the problems that you guys have out there that this could apply to? So we're really hoping that this will get your creative juices going so you can say, hey, this is a technology that I might be able to use to solve some problems. So talking about cutting edge and emerging technologies, I do want to say that this is an outreach of the Manufacturing USA institutes. There's 14 of these Manufacturing Innovation Institutes set up as public-private partnerships from the federal government, and each one has a unique technology concentration. So flexible hybrid electronics is one of them, and I'm going to talk about NextFlex. It's the Innovation Institute out of Silicon Valley. But there are 14 other ones that if you guys are interested in advanced composites or biopharmaceuticals, smart fabrics, the digital thread, there's many other emerging technologies that you may be interested in. So today what we're going to cover is, what is an overview of flexible hybrid electronics? Why is it different from traditional electronics or different from what is available currently? Why would you be interested? What is the business case? What is the use case for your manufacturing interest? And, where are we as far as current technology? What can we do with FHE today? Because it is an emerging technology and every day there's new advances. And then FHE resources, how can you get connected? How can you build upon this and learn about these resources? So to get started, what is flexible hybrid electronics? So I like to start with this because a picture is worth 1,000 words. And so if you take the left picture, which is a flexible substrate with some very simple circuitry on it, this is something that you can buy and manufacture today, just a simple flex circuit. And the second picture is going to be an integrated circuit, an IC, whether it's a processor, memory, some kind of A to D or other sensors. Those are typically in a package placed on a rigid PCB board. So what we want to do is get the best of both worlds, because today you cannot put complicated integrated circuits on a flexible substrate. But that is exactly what flexible hybrid electronics is. It's taking the smarts, the sophistication of an integrated circuit, making it flexible and putting it on a flexible substrate. So that picture on the right is an example of a very simple flex circuit where you actually have silicon die that is flexible. I know you think, how can silicon die be flexible? We're going to talk about that in a little bit. So using words, it's really, we're combining the flexibility of that plastic film substrate with the performance of a semiconductor device. This is a new category of electronics that the applications are really to be discovered. So, what's different about flexible hybrid electronics? Well, right now, the majority of electronics that we have to be protected. You have to protect it from moisture, from water. You have to protect it from static, ESD charges. So you've got all our electronics in these enclosures, in these boxes. So we're going to take these electronics out of the box and protect them, and you can actually make them flexible. So that's an actual circuit there that is being flexed. It can be stretched and contorted. the technology to actually make it stretch is that they're using inks that are inkjet, conductive inks that are inkjet printed on a plastic or flexible substrate. So if you think of, an inkjet printer, you're just printing a conductive ink, and so you can stretch that and not lose conductivity. It's going to be conformable, even transparent, and it's biocompatible. So a lot of these applications can be used on the body now. Think about some of the applications today. Over the past 3-4 years, we saw the big rise of the Fitbit or the smartwatch, where you were measuring your pulse and some other parameters, but you always had these electronics that were in this box sitting on your wrist, right? Well, now with this new type of electronic, FHE, the applications, really, it's going to be very interesting to see what comes out of this. So some examples today of the conversion. So on this picture on the left is a standard, rigid PCB, and it's been converted to a flexible PCB. So that's a flexible substrate there, and you can see the components on this example are still discrete components, but the entire circuit itself is still flexible. So this is an example where the actual component is flexible, and the way they do this is they actually take the semiconductor wafer and they thin it down to about between 20 and 25 microns so that it is actually flexible. So you're not going to be able to bend it at a 90-degree angle. It doesn't have that type of flexibility, but at this point, you still can flex and conform, let's say, around different radiuses. Now, this one is that stretchable measurement circuit. This is an actual circuit. I've held this one in my hands. It's made by Jabil over there in Tampa. And you can see that the conductive ink used there stretches and does not lose conductivity on that circuit. So these are some examples of FHE today. Some of the building blocks that can be used are going to be the traditional building blocks in a traditional circuit. So your smarts, your microcontrollers, your sensors, obviously your power sources. These are all the building blocks of a typical electronic circuit. So antennas, microfluidics is basically the circuitry required for like inkjet printers. Communications, you've got, how do you use your sensors to get your data out with Bluetooth or Wi-Fi, and again, your memory. So these are all building blocks that are available and being developed today to be used on FHE. What are the applications? Once again, this is really up to you guys to kind of identify and see where the problems are that can be solved. But the top line there, portable devices or mobile devices where size and weight is important. These components are going to weigh less because they don't have that board, the PCB board, fiberglass board underneath it, printed circuit board. Applications where conforming to a shape is important. Maybe you have an application where, man, if I didn't have this square, flat circuit, if I could just place it along a surface inside a radius, inside a cone, inside a tube, inside a pipe, wouldn't that be useful? There should be a lot of different applications for that. Disposable at high volumes. Some of the applications that people are thinking about is printing sensors and memory into labels. So you can print a label and you stick that label with whatever sensor you want and measure in very, very thin and very, very cheap at high volumes. So hopefully you guys are starting to think of maybe some applications where some of this could be used. What is the business case? Why would I be interested? And really, I want to talk about innovation in this. It's a new emerging technology. Think about the internet. When the internet came out, maybe, what was it, mid-90s or so, and I distinctly remember seeing the internet and thinking, wow, that's really neat, but what is it good for? We didn't understand what the applications were for the internet, but today we couldn't live without it. And the early adopters, on this new technology are the ones who are going to benefit the most. This technology is coming. It is not something that is kind of pie in the sky. Europe is investing heavily in this. Asia is investing heavily in this. And the United States is investing heavily in the development of this technology. This FHE is going to open up new applications, potentially new revenue streams. So once again, the early adopters are going to be the ones who kind of figure this out and identify how can they monetize this flexible hybrid electronics. So also, talking about existing products or even existing production. So if you're a manufacturer who isn't necessarily create their own products, FHE can still be of extreme interest because you can use FHE and the sensors within your manufacturing line. Is there some place within your process that if you had information, if you had that sensor, if you had that temperature, if you were able to monitor that process and get that data out, that you could become more efficient and therefore become more profitable? So it's not only new products, but it's also improving your existing processes. And lastly, why would you be interested? This is really of national importance. And part of what we're doing today is bringing awareness, and there is adoption assistance available in the form of money. So if there is an application that you feel you really could help with, or you could use some help, and this would make sense, we need to talk, because there is some potential money grant assistance available to help drive this technology forward. So I do want to talk about enabling technologies as an example. I believe that for flexible hybrid electronics is an enabling technology. And what I define an enabling technology is a technology that integrates itself across many different industries. And you may not specifically go buy this technology by itself, but it improves products and processes all over the place. So some examples here: 1907, synthetic plastic was invented. So my guess is wherever you are sitting today, right now, within arm's reach, you have plastic, very close to you, whether it's in a mouse or your monitor or even your phone. You are within arm's reach of plastic. That's how much plastic is in our society, really. So much so that plastic is in our currency. It's in our money. So if you think about that, in 1907, who would have thought that plastic would be in our currency? But there it is. And also, this is an image of a Tesla. From what they say, this Tesla is about 20% plastic. So even our cars are going in that direction. Another example of enabling technology is the integrated circuit, the IC, invented in 1958. Once again, the IC is in our money. I think we've all probably gone through the upgrade to our debit cards, where we got the little smart chip on there within the past 12 months. And also, the integrated circuit in our cars. Very difficult now to work on your car. You can't work on your car like you used to before. There's a lot of smarts in our cars today. So these are good examples of enabling technologies. I would like to propose that flexible hybrid electronics is an enabling technology. So what does that look like in our currency? Could we have a display? Could we have, could you fold that credit card up in half or in a quarter instead of having it to be rigid? This picture here is the inside dash of, I believe it's of a Honda Accord or Honda Civic. And you'll notice the display right there in the center. It really looks like you took an iPad and just kind of dropped it onto the dashboard. And that's the state of the art of the technology today. But in the future, what we're going to see is we're not going to see that discrete kind of dashboard or display there. I believe is we're going to see the whole dashboard is going to be a display, and certain applications are going to pop up in context. So you're not just going to have an iPad kind of sitting on your dash. Your whole dash is going to be a display, and you're going to be able to touch your dash and manipulate, whatever, the air conditioner or the radio, however you want to do that. So those are some potential applications coming in the future for flexible hybrid electronics. So you may be familiar with the product lifecycle. So this is talking about revenue on the vertical axis and time on the horizontal axis. And any certain product that you have or product line is going to go through this type of cycle where you introduce it, it grows, and then maturity and decline. So for most of our products and most of our companies, we operate in the maturity phase of the product life cycle. And in the maturity phase of the product life cycle, what we do is we compete with, other competitors through operational excellence. We try to make things more efficient. We try to control our supply chain. We try to control our processes. We try to do things better and better, more efficient to be able to compete. So most of us are within that maturity of the product life cycle. If you go back to the sales side, if you may or may have some products that you've had in the past that you introduced, and then when it started to take off, it got to the point where your salespeople, they weren't selling it, they were just order takers, right? People were just, hey, I want some. And the problem wasn't sales, the problem was actually ramping up your manufacturing to meet the orders. So that's part of the growth phase. So if we put a profit line in here, you can kind of see that during the growth phase, profits are increasing, but in the maturity phase, profits are either flat or decreasing, and that's due to competitive pressures. So why do I show this to you? Because if we are mostly operating out of the maturity phase, how do we go back to the growth phase where our profits are increasing? And how do we avoid the red decline phase? And that's really through that innovation, kind of developing that new process, developing that new product. And this is where flexible hybrid electronics can fit in. What are the applications that you're able to develop and bring to market where you will have a competitive advantage for a certain amount of time, or take that flexible hybrid electronics into your manufacturing process, and you are able to extend your maturity phase because now you're in a better position to compete. So that is where this flexible hybrid electronics can fit into your innovation strategy, really. So, what is the state of the technology today? So So I did say this was a cutting edge technology. You cannot go out and find a catalog and order a flexible circuit. You can't, it's just not there today. And so where are we on this technology? We're developing it. So you may be familiar with this graph, but what this talks about is MRL levels, which is manufacturing readiness level 1 through 10, going from left to right. And so MRLs 1, 2, and 3 are really developing those basic manufacturing proofs of concept and saying, hey, this is a technology that we have identified in a laboratory setting, and we feel like we've proven that it works, and the science behind it has been proven. On the other side, the MRL 8, 9, and 10 is where the full rate production is available. That's where you can pull up a catalog, or you can find multiple vendors out there who would be willing to sell you, flexible hybrid electronics. If you want a circuit board with memory and Wi-Fi on it, that's flexible, it'd be kind of an off-the-shelf type of endeavor. We are not there. So where we are is we're trying to bridge this gap between number 3 to number 8, and it's the chicken and the egg, because how do we develop those high rate, high volume processes for manufacturing when we don't know what the applications are? So that's really what we're trying to do, is we're trying to bring awareness to industry so that the applications can be identified, so that that money and that effort, I should say, can go into the developing of the high rate or the volume type manufacturing. So that's the process that we're in, is MRL 4, 5, 6, and 7. So this example here is probably an example of the most advanced FHE application. This is actually on the market. You can go to Amazon and purchase this. It's a continuous body measurement for a sick child. There's a little patch. It's a flexible patch that has a temperature sensor, has a battery, it has some memory, and it has I believe it's a Bluetooth controller that'll communicate with your smartphone. The application is, if any of us have had a sick child, you want to know what their temperature is overnight, but you don't want to wake them up at 2 in the morning. You don't want to poke the bear, but you really want to know if they're running a fever. So this has a single-use battery, and it'll track and continuously monitor the child's temperature. Send that information to your smartphone app, and you can set a threshold. So let's say if you want to know if your child's temperature goes above 100 degrees, it'll wake you up. That's the application. So you can get this, I want to say it's under $20 off of Amazon. So this is the most advanced application that I've found of flexible electronics. And the reason why it has to be flexible is, can you imagine putting a square box, on your child? It's not going to work. They're going to wake up. This is a very thin film that has some adhesive on it, and just it conforms around the baby's body. This is another application that's coming down the pipe. You may be familiar with an Arduino board. It's basically an open development board that you can buy today with a traditional technology that's in the picture in the bottom right-hand corner, but it's being developed with flexible hybrid electronics, and it's going to be available, here in the next couple months. So if you have some applications that you think you might want to play around with, this might be an opportunity. Get this Arduino board, play around with it, give it to your software developers, and just play around with it. I'm not going to go through all the details in here, but these are some of the examples of projects that have been developed. This is through Purdue and Indiana University and Western Michigan. But this is a smart wound dressing, like a bandage, that's going to measure the amount of oxygen that's on the wound and deliver oxygen if it senses it needs it. So this was actually built, prototyped, and tested. So it's like a Band-Aid or a smart bandage with an oxygen sensor in there and an oxygen delivery mechanism. A lot of bio applications. This is a flexible EKG sensor. So if anybody has ever had to go get, EKG monitoring, they take these little stickers and they have hard wires and they run them to the machine. And you can't really, you have to be very, you're tethered to this EKG machine, right? You can't go too far. Well, with a flexible EKG sensor, they can attach all the sensors to your body. It can have a Wi-Fi and some memory and a Wi-Fi wireless communications, and so you have freedom to move, and so the applications for this are very, very interesting. So, those two prior examples are kind of, the MRL, kind of the lab. Hey, we've proven the technology. Now, the next couple of examples are really, really the science side of it, very, very early on. But 3D conductive material that can be used basically at a 3D printer type level or low-cost 3D printing of batteries. So developed by NASA. Once again, biocompatible touch sensors can be printed directly onto the human skin and sensitive enough to monitor a pulse. So a touch sensor. This is a very interesting piece of technology. I'm not sure what the application is, but it's electronics that dissolves in water. So you can actually print it. You can see on the very left picture, that's the circuit printed at 0 minutes, placed in water, and over time, it just dissolves and disappears. So it's an electronic version of invisible ink. I guess, maybe the military would find some applications for this. So I do want to talk about FHE resources. How can you get involved? Where can you plug in? So I want to talk about NextFlex. NextFlex is one of those manufacturing innovation institutes that I mentioned at the beginning of the webinar. It's a cooperative between the DoD and Flex Tech, which is the Flexible Consortium. And basically, it's a group of companies, universities, academic institutions, of which Georgia Tech is one, and the Department of Defense. And really, they want to advance the U.S. manufacturing of FHE. This is the DoD is involved because they feel like it's of national importance that we want to be able to not only be leaders, or not only to stay abreast of the technology, but we want to be leaders in this technology because the country or the region, let's say Asia or Europe, if whoever develops this flexible technology first is going to have a huge advantage over the next 15, 20 years in manufacturing electronics. So we talked about this group or this graph. What NextFlex specifically does is it's going to take projects from the MRL3 and try to advance them to the MRL7 level by coordinating resources and providing funding and structure to solve problems. And so when I say solving problems, this is going to be typically pre-competitive problems. So a pre-competitive problem would be, for example, how do you print, the flexible batteries at high volumes? Or what is the testing standard for flexible circuits? The whole industry can benefit from those type of cooperation. So it's a pre-competitive type coordination. And once that technology is developed, let's say at MRL 7 or 8, then that becomes released to industry, and then people can use it to develop their own proprietary applications. So NextFlex is really focused on awareness and education. That's exactly what I'm doing today, is kind of bringing some of this information to you. On-site and remote training. They actually are doing a lot of workforce training in Silicon Valley right now at the community college level and even at the high school level to bring our workforce and have them be familiar with this type of technology, because we feel that we need to have the workforce educated to be able to work on this technology over the next 5-10 years. Networking, talking about connecting with supply chain partners, all the way from, the folks, if you are a printer or, make printing materials, you really need to be interested in this flexible FHE, because many of the technologies to make FHE use printing technologies. And, really advancing FHE manufacturing technology. So how do they do that specifically? They do that with project calls. A project call is a specific topic that industry has identified as something that they feel like needs to be addressed or needs to be pushed forward, needs to be solved. And I'm going to give a couple examples of that. And there's cash awards to proposal teams. And this is pre-competitive once again. So some examples of this, you can see the team here was United Technologies, Excellent, and Stanford University. So those three groups came together with the NextFlex funding to solve the problem, basically, of developing large area strain sensors. So what's a large area strain sensor? Well, it's a mesh of strain sensors that can be put, in this case, onto the wing of an aircraft to measure strain and stress on that wing. So you can see where these applications, are very unique and interesting. So they actually developed this. This is something that is out there. They developed a large area strain sensor. Another example, this is actually a group got together, Jabil and Boeing and GE and some other folks to start developing the actual machines for the high scale, high volume production of flexible hybrid electronics. So today, if you want to build traditional electronics, if you're going to be a contract manufacturer, you can go out and purchase machines that build traditional electronics. Well, if you want to be a FHE contract manufacturer, those machines do not exist today. And so this is part of that development process to develop that technology. One of the things that NextFlex is doing and in the process of doing is they are putting together a process line, a manufacturing line for flexible hybrid electronics in Silicon Valley. So if you have a circuit that needs to go to production or you want to build prototypes, they have a platform where you can actually go and have it built. And if you are a contract manufacturer, then this is part of a process that you'd like to be part of to understand the technology and to be part of that team developing the technology so you can benefit. So this is the most recent project call. These are some of the high-level problems that they were looking to solve. It's not that this is just some examples. There are many more of this, but RF and high-speed applications, 3D component placement, monitoring applications for physical or perishable assets. So this is kind of, I explained a little bit before about the labels. If you had a label, let's say that could track and measure temperature, and you wanted to mail some medical supplies, insulin, let's say via FedEx or UPS, you know that when you sent it, you kept it temperature controlled, and you know when it was received at the other end, it was temperature controlled, but you have no idea what happened to that insulin, you know, in the 3 or 4 days when it was on the truck or on the airplane. So with this label, with a temperature sensor and some memory, you just slap it on your package, and when you receive it on the other side, you read it back out, and you have a temperature profile, and you can say, okay, this box was maintained, you know, through a acceptable temperature profile, or it wasn't. So those are some examples of monitoring perishable assets. So just as a highlight, you know, what we covered today, kind of a high level of what is flexible hybrid electronics as opposed to traditional electronics, what the business case would be, you know, where we are. It is cutting edge, and so you can't go out and buy it in a catalog today, and how to get involved. So at this time, I will pass it over to Phil and see if there's any questions. I'd be glad to help answer.
Thank you, Andy. Yes, we do have some questions for you, and I would like to just remind our audience that if there are any other questions that you still may have, we have enough time, I think, to go over them. Please use the question pane to record those. The first question that I have here for you, Andy, is it says that we're an engineering company that helps manufacturers in product design, and if our clients have products they'd like to improve, what would we have to do to get involved with possible implementation of FHE in the product?
Okay, so I think probably the best thing to do is NextFlex has different levels of participation, and one of the levels, kind of the entry level, is an observer level. And so if you really want to kind of stay in the loop with where the technology is and what's available, because that's probably one of the things that would benefit you guys the most is, you know, what is available that I could integrate into these solutions. That would probably be one of the things that would make sense, is to kind of just get plugged in and connected with this community, and you get to know the players, you get to know the suppliers, you get to know what technologies are out there, and so an observer level at membership with NextFlex would probably be a good start. And then, you know, there are different levels if you want to be involved in the actual projects and stuff. But I would recommend just kind of getting in contact that way. And that's something at the very end of this webinar, when we close out, there's going to be a survey that pops up. If you guys would please take the time and answer a couple questions, because that's where we're trying to get some info from you guys as far as what kind of applications and challenges you guys are facing. And at the very end of that survey is, if you would like, you know, more information about NextFlex, you know, give us your contact information. So that's where you'll, you know, put in your contact info there, and then we'll make those connections for you.
Okay. Yeah, I had another question, which is sort of answered. It says, can a small manufacturer have access to the FHE technology without a formal participation? I don't know if there's anything else you'd like to add to what you had just said about that.
Yeah, and so I would just, and you don't have to be a member of, you know, of NextFlex. There's a lot of information. Well, maybe not a lot of information, but you can just go out and start looking, you know, through the web and kind of going to conferences and stuff like that. But probably the easiest way, where it's all concentrated, is going to be, you know, through NextFlex or Flex Tech. Those are two different industry groups. So I would recommend looking at those two groups.
Okay. A question here is about the current applications of FHE, has that been used in a display, a display application yet? Do you have any examples of that in a screen or something like that?
Yes, and curiously enough, NextFlex has made a conscious decision not to focus on the flexible display market, and the only reason why is because it's its own beast and animal unto itself. Printing or manufacturing flexible displays it's a very niche technology development, and so what NextFlex really wants to focus on is a broader technology development. So to answer your question, NextFlex isn't associated with the flexible displays, but there are definitely, prototype flexible displays that have been shown at trade shows. It's, once again, not quite ready for prime time production, just because the volume, the technology isn't there to create it in volume where it makes business sense. But they're working toward that, believe me. Whoever develops that first is going to be bringing it to market.
Okay, thanks, Andy. I've got one more here at this point. If, as a manufacturer, I want to participate and use the technology, what kind of responsibilities do I have? What kind of load, does it put on me to participate in FHE and to find a way to use the technology?
Well, I guess I would say you probably need to have some resources on the design side, whether, have some electrical engineers or maybe even mechanical, packaging designers, engineers on your staff, and to be able to have the bandwidth to experiment some. So if your industry is so cutthroat that your margins are, very small, and that's going to be very difficult. But you've got to have a little bit of time and money in the sense that, can you allocate some of your engineer and your design and your R&D time to this effort. So I would say, it's the applications and the solutions haven't been identified yet, and that's part of what you're going to be figuring out. So if that's something that you as a company are familiar with and do on a regular basis, then it's not any different really than any other technology. But if you have never integrated a new technology, then yeah, it's going to be a big step to get involved with this. Okay.
And so the last is actually more of a comment, Andy. So really the bottom line for a manufacturer or an engineering firm that could see some potential improvement in a product to take advantage of some of the benefits of flexible electronics. Really, I could take, as a manufacturer, my current product and see if there's some way I can replace the non-flexible electronics with flexible to make the product more valuable to my customers. Is that essentially correct?
Yeah, absolutely. Either a final product or a in-house process in your manufacturing line.
Okay. All right. Well, thank you very much, Andy. As noted earlier in the recording. Oh, go ahead, Andy.
One more comment. So I want to thank everybody for participating today. And it is very important if you could take a couple minutes to fill out the survey. We do want to kind of understand where you guys are as industry and what your thoughts are. And if you are interested in taking that next step and just becoming plugged in and connected, please put in your contact info. So, thank you.
Thanks, Andy. And as noted earlier, again, for our audience, the recording will be provided to everyone within a few days. If you'd like to find out more about the technology and some applications, feel free to contact us, either me or Andy, as you can see on the screen, our contact information. Also, just for your information, we will be conducting several face-to-face awareness sessions similar to this early in 2018 around Florida. So you may have some colleagues who would also like to be in, who have an interest in this, can participate then as well. I do thank everyone for attending today. As Andy asked, please complete the survey as you exit the webinar. We're seeking information about your interest in FHE, and we'd also like to have feedback about how to improve these webinars and better meet your needs with topics of value to you. Thanks for attending. We do not have a webinar next month in December, but we will be back again in January with the monthly series. Thank you all.